Welcome to the City Futures Research Centre seminar series. I'd like to acknowledge that we're meeting today on the traditional land of the Bidjigal people of the Eora Nation, and would like to pay my respects to the elders past and present, as well as any First Nations people joining us today. If you are joining online, please mute your microphone and turn off the camera during the presentation. Once we get to the Q&A, you're welcome to turn your cameras back on and unmute yourself. You can also put a question in the chat, and we'll be monitoring the chat throughout the presentation for questions. Today, we are delighted to welcome Dr. Balamurugan Soundararaj. Bala is a research fellow at City Futures Research Centre. He is a part of the award-winning Value Australia project, which integrated cutting-edge research, significant data assets, state-of-the-art analytics, and machine learning artificial intelligence to deliver secure valuation models and tools covering a broad range of land and property types across Australia. With a background in urban planning, spatial analysis, and human geography, he has 8 years of experience working, teaching, and consulting in both academia and industry. His core research interest is the collection, analysis, modelling, and visualisation of large-scale spatial data, with a focus on solving problems in visualising and communicating complex methods and their outputs effectively and transparently. His presentation is titled Leveraging Artificial Intelligence to Improve Planning and Housing Development, a study on planning application, classification and analysis using natural language processing. Over to you, Bala.
Thanks, Georgia. Hoping I'm audible to everyone. So that was a really great introduction. Thanks very much for that. This was a presentation which we did for computational urban planning and urban management earlier this year. So basically, it's part of it constitutes two years of work we've done. Yang, William, Sedan, Hoon, Chris, and I have done as part of ADAP, Australian Housing Analytics Platform project, and Housing Analytics Lab right now. So before we go, I would like to acknowledge that we have the country we are meeting in, which is a very Bidjigal and Gadigal and involved people, for the traditional owners of the land. I'll structure the presentation in four quarters. I'll introduce the studies in the first 15 minutes. Then I'll move on. There are 2 sub-studies there, so I'll spend 15 minutes each, and I'll leave 15 minutes for discussion at the end. So to introduce, so being part of City Futures, and after having the conversation, like a seminar series last seminar series by Chris and Ed, we don't need an introduction about housing, the problems we have in housing, and the range of complexity that's in this crisis. So we have targets. We have it's a wicked problem which has multi dimensions associated with it. So there is a supply dimension. There is the planning regulation dimension. There is in terms of affordability, there is a demand side dimension. So there are a lot of questions we ask in our effort to solve this crisis, which starts with information and how do we get those information and how do we make sense of the information we have. So basically what we see is we tend to ask questions saying, so we have a plan to build 1.2 million well-located houses by 2029. So that's the broad high-level policy. Then we start asking how far along are we in this process? So then we go back and say where do we get the data to track this? Where do we actually what are the sources where we can look at which can help us identify and track these metrics which we want to achieve? So that's where we see an opportunity in the planning application and development application process. So on the top right is basically a work done by Rob Kitchen in Ireland. So basically they mapped the process of planning and development applications, and what are the processes and the places where these applications are held. So it shows the complexity of how much data is in there and how much work that goes on to getting these systems set up and done. So there are like a lot of people looking at like using AI to accelerate these things. So to start with, like a planning application or a development application or development permit, planning permit, whatever we may call them, it's required for a new build or any subdivision or land use changes. Anything that changes in the built environment will go through the process of having an application process beforehand. It's publicly available, so there is it's almost it's usually like shown to the public before the approval process goes through, and it's rich in terms of like how much detail that's in the planning application is not us. Right? So it usually has a lot of information on what's going to happen, and it's also internationally equivalent in countries such as like US, UK. So they all have equivalent solutions and similar processes. So we also see there is an opportunity to get insights which are into the supply pipeline using this data set. And the key advantage I see with this is like it's actually kind of a forecasting for 1 to 2 years. It's not something which has happened, it's looking into the future. So it's very unique for this data set. And we can also like then start use it to do other provisions, like client provisions, infrastructure provision to align with this. So basically, what we are looking at is opportunity where we can in a data-driven way predict or like look into the future on what's going to happen in the built environment. So that's very unique about this data set. So so in terms of like what's happens in Australia, it's so we started the process when Chris and Yang started looking at it at ADAP, saying, can we get like a comprehensive planning approvals data set across Australia? So we kind of started noticing that like there are like it's usually done at a LGA level, local government level. So it's collected across 537 councils and jurisdictions, and there are like different naming conventions. There are different other equivalent. There are different processes and cadence to these processes. So storage formats and the way public consultation is done is also like there's a lot of variability there in terms of how it's done. So it also has a lot of textual image-based data, which are not very easily processable compared to like traditional census data equally. So the table shows like a survey of all the different planning application equivalents in different states and territories, and how much time it usually takes for them to do decisions around that. So that brings us to the challenge, right? So the challenge we want to tackle is assuming that we have a comprehensive coverage of all development planning applications in the country. So can we answer this question? So one is like, how many new dwellings are in the pipeline to be approved by 2027? So if somebody asks the question saying like, okay, so looking at the, if you have the comprehensive information, data on the planning application, can you, how would we go about answering this? So basically there are two parts of the question. One is the new dwellings part. Another one is the approved by 2027 part. So there's a typology aspect to it, and then there's a temporal aspect to it. So when we say planning application, everything requires planning application. So being able to then spot and isolate the feature we want from those applications and being able to say like what that application is for. That's the first, solving the first question. And the second one is being able to then in the process of the application is just one part of the whole process, which starts with submission of the application, public consultation, and then it gets to building approval, construction, and finally the dwelling comes to live. So how do we then, using the tech methodologies we have, how do we make a educated guess or educated model of how predicting this? So today's presentation basically is part of the two works we have done. So one's done by Yang and Will on the classification, the first aspect of typology. The second one is, which is in review currently, the preprint CR, so which is on about doing predictive analytics on the temporal aspect. So So the next 15 minutes, each like half an hour, I'll go through each one of those presentations and what we have done them. So to start with, collection and classification. So we are looking at the first aspect of the question. So we started from saying like, okay, so there is a development application process. It's varied across multiple jurisdictions. So where can we get the data about them and in a consistent way across the country? So there are multiple sources we found. So one is sometimes it has like there are state level platforms which we can use. For example, New South Wales has its planning portal, which tries to act as a state level platform where this can be managed. All the planning applications can be managed. The second one is the local government level. So the consultation process involves putting up those applications for a specified period of time. So we can collect them using their websites. And you have like services which can give us the information such as planning alerts, which will give us if there is a application lodged, there can be alerts which can be sent to you. So there is also like size of the application changes. So in terms of like, is it depending on whether the size of the application, it can be either a state significant application or a application at a local level, which is a development application, TA. So we started with collecting this local government websites and state websites. So the Yang worked on this for close to 6 months, trying to get a multi-step process, cloud-based process, which is using Python to scrape the websites from about 300 odd LGAs and geocoding them. So often these are like textual information which has addresses in them. So geocoding them to a location and then filtering and cleaning the data and getting to a point where we have a collection of DAs which are consistent in terms of what data points it has. So essentially, we ended up with from the original text, which is on the website for consultation, we can then convert that into a table which has location information, which has temporal information of when it is launched, and then it has information on what the actual application is. So as of August last year, there are like around 375,000 records. So now it's close to 400,000. So this happens every day. So the script runs every day in AWS and keeps collecting the information on a regular basis. So for the past 2 years, we've been close to comprehensively collecting this information across Australia. So although there is variability in terms of like New South Wales, Victoria will have more coverage than other states. And then some states, like for example, South Australia has more coverage in terms of temporary, so it has better historical data than, for example, New South Wales. So that's the data collection process. So what we end up with is like around 400,000 records of development applications and a text on what they are about. So the next question is like, can we classify them and isolate the new housing development out of them? So we started with looking at classifying them into like 4 categories really. So in terms of which one of them are commercial, which one of them are new dwelling developments, subdivisions, and alterations and modifications. So this will give us like, so where the new, say for example, going back to the question saying where are the new housing developments are coming in. So we can pick new housing developments and possibly subdivisions, which will also have a subsequent DA for housing house construction. So then we used 3,000 odd manually labeled training set. So basically, this is set in and helped us in doing this training set of like looking at the description and manually classifying which category these things fall in, so that we can use a pre-trained transformer-based model to then create a model which can do it automatically. So we used multiple models, word to vec, which is at the top, which is kind of like converting natural language into a number representation. Then you have like text CNN, which is a convolutional neural network based process. Then the new ones, which are BERT and ZSL, which are transformer based models, which pre-trained in language to do the same thing. So this is pre-ChatGPT become famous. So you can imagine BERT as a very, very small ChatGPT, which you can give examples of how to classify information, and then it uses that information to classify it for the future. So 3,000 odd training set goes in, out of which 60 is for 60% of it's for training. And that gives us the ability of we can make a model which can do it for the rest of the 400,000 records. So we applied that for Sydney and Melbourne to see like how the classification works. So we got a 96% accuracy in terms of classifying and identifying what type of planning application it is. So to compare the different models we use, so broadly there are supervised and unsupervised. So supervised uses that 3,000 odd manually labeled data set, unsupervised doesn't. It kind of looks at the distances between the vector representation. BERT was like when we started the work, BERT was kind of like a cutting edge in terms of an NLP model, which can be used for classification purposes. It does 12 odd NLP tasks very well. So we use this for classification, out of which, so DBERT version of, so BERT has like different types, different flavors of the same model. So we found the one which works around 94% accuracy. So when I say 94% accuracy, it's about the way we do it is like there are 3,000 records. You take 60% of that for training. So that's 1,800 records, which goes into training the model. Then we test it on the rest of the 20% validation. Like 20% is for testing, which kind of shows that like 94% of it is right. So it's tested across against the ground truth. So once we have the classification, what can we do? Right. So we can see when we plot that across Sydney on a map, then we can start seeing patterns there. So this is essentially points. Each point is a planning application, like development application, and the color shows what type of development application it is. So you can see where the non-residential, commercial clusters are, where land development subdivision clusters are, and the new housing clusters are. So the key in interpreting this map is it's not what's happening, as in like it's not currently, or it's not a historical map. It's kind of like looking into the future. This is about the application that have been launched. So if all of them get approved within the time frame, then this is what we're looking at in terms of where the new housing clusters are going to be, where subdivisions are going to happen next. So we did the same for Melbourne to start getting clusters of like where land developments are going to happen. And then you can also do temporally as well. So we had like 23 and 2021, 22, and 23, 24. So the data, the last 2 years or 4 years of data was like comprehensive for us. Then you can see how the clusters change across temporally as well as we move along. And if we actually have the data, then we can compare it, see is it how much is that is true. So to summarize, basically, like this was published last month. So it summarizes the work we have done. To summarize, we do a lot of modeling using multiple methods to inform our vision of the future, how the built environment is going to change. So we do cellular automata models. We do like a lot of complex modeling methods to using what's already there and predicting where it will go. And what we have done is like took a look at the opportunity of using planning applications or development applications data to inform those future predictive models in a much more concrete data-driven way. So if one of our cellular automated models predicts that like a certain area is going to have like a housing development in the next 2 years, that needs to be based in reality. So that there needs to be applications launched already, which should be approved so that like they can be in line to be delivered in 2 years. So that's one part. Second is like it also gives us a way to answer the first part of that question, saying how many new houses, then we can pick that the houses element can be solved. So that's the first part of the presentation. The second is timeline. So when we see that when we have this information, the first reaction we will have is like, yeah, so this is an application. It doesn't guarantee that it will get approved or it's going to get built. So even if there is like 500, 1,000 applications in Rosebery for new dwellings, and what are the chances that they're going to get built? So that's where the timeline predictive analytics part comes in. So this one we started with the data set we had before in terms of what the data points we had, and we quickly realized like to do this kind of predictive analytics, we need like a lot more data dimensions of the data. So that's where planning portal was instrumental in getting that data to us. So the primary source was like New South Wales planning portal, which we got data from 2021 to 2024, and we captured so you can see the first part, PA attributes. We captured all the aspects of each application which is being launched. So for example, cost of development is a field. So for each planning application in the planning portal, we have a cost of development as a field. So when we are looking at like predicting whether it will get approved or when it will get approved, that's a good information we can use. So, and then we also linked it to other information from New South Wales seed portal, which gives us EPI, environment planning instruments across the state. It kind of there is an aggregated version from there. So we also can link that to the PA. So for example, if a PA has been lodged, and if that PA has an EPI apply to that, so we can link that. And finally, we used descriptions we got from the previous study and link them together using address and time. So what that leaves us is like a very even more richer data set, but smaller data sets. It's like 17,000 in total. So across Australia, which we have a complete data on what the planning application is for, what are the aspects of it, and then like it's like what size, and then associated information of like which zoning, which EPI apply to it, and then description of it. So, and that most importantly, the time series, when it was launched, and when it was lodged, and when it was approved. So these are the two information. Okay. And then we started doing some feature engineering to have like an extra information in there. First one is the council index. So we also noticed that like LGA have a different index of how long they take to approve some certain things. So that kind of becomes an index in the that becomes a feature in the data. Then we can also see like lodgement month. So the time a planning application is lodged will affect how long it takes to. So for example, comes from if you lodge your application at like December, it's guaranteed that it will take a month. So there is a seasonality to it, to when you have a large application, which affects your outcome and the time frame. Then there are like text features, like how long is the application, what's the category of that, and we can use the previous model we built to do the category. Then we clean the data for one things with only verified date fields to them. So we know that like the lodgement date and the resulting date are approved. So with the initial idea was like when we started this, Will and I was looking at saying, first, let's predict whether it will be approved or not. Then if it is going to be approved, what's the chances of that it gets approved within a time frame? But then we realized like quickly the data set which is about planning applications which don't get approved is very, very small for such a study. The reason we found is like it just sometimes like because of the process of the applications going back and forth, the lodgement it will just remain open rather than getting rejected outright. So it just takes longer time. So the final data set is 17,000 long across 88 councils across New South Wales, which has a comprehensive data on what they are. So the next task is to actually model what would be the time it would take for it to get approved. So looking at like lodgement date and decision date. So what will be the difference between that? So we used content regression at like 50th and 90th percentile. So basically we wanted to predict what the 50% chances of like how long is it will take with a 50% interval, right? The 90% confidence, like how long it will take. So let's say take a shed, like a shed at the back, a residential shed. We can say with a confidence that like 90% of percentile prediction that it will get done in like 30 days or something. So it will get approved in 30 days. We use multiple models, mostly on random forest models and combined with some gradient boosting methods. So gradient boosting basically takes multiple random forest approaches and weights them together to give the best results. So essentially the results were as expected. So we got the best result with gradient boosted models, like for example, XGB in so the R square is like basically the most accurate predictions. I do want to point out that like it's not. So the initial idea was to get like a number of like how long it will take this to get approved, but the accuracy for predicting that is like quite low because how variable the data is in terms of like timeline it takes for a planning application to go through. It's quite hard to put confidently predict that. So basically, it's like R square of 43% is what you can get in terms of saying it's almost as equal to like it's not great. But that being said, like then you can do we can say with a predict with the varying predictability, say like, what's the estimate for a 90% chances will get approved, so that we can do. We also try to model which features influence the timeline of planning approval, planning application being approved. So, for example, so this is a sharp plot of various factors. So there are other 202 other factors which we haven't shown here, but the top 15 are here, which is the first one is the cost of development. So a cost of development being high indicates like which will predict the time it will take. So basically, if the cost of development is high, it can add like 15 days to the application. So each unit to there. Which council the planning approval is? The councils do have a set aspect to them, and then features like words in the proposal, which are simple as like complexity, number of dwellings, and then the interesting ones are EPI variation proposed. So if there is an EPI variation proposed, it takes longer. And then, for example, if it is dwelling, it takes less than if it is otherwise. Development type dwelling, and then month, if it is December, it adds like one more month. So basically, these kind of we can go through and investigate why the prediction is like that. Finally, I wanted to show two examples of how we interpret these results. So the left one is residential development application in Orange, New South Wales. So you can see it's a construction, the description says it's a construction of a detached dual occupancy and refer to our lecture P of subdivision of land. So it's part of like a broader application. So the most influence, it was a very long application. So the number of words in them kind of added 20 days to it. The council is usually very fast in making decisions. So the index of the council adds like 17 days to it. it's a subdivision proposed, so it adds 15%, 15 days to it, and so on and so forth. The same thing we can see in and the bottom. We can see it's 50% chance of this getting processed in 143 days. 90% chance that like 90% of such application will get processed in 204 days. So that's basically what we're expecting for the subdivision and application to go through. Like 200 days would be a good indicator. And then the residential deck in a Wollongong house, cost of development is 15,000, so it like reduces 12 days of the mean, which is 54. And then like so, basically, it's again it's launched in December, so it increased by 12 days, and so on. So we can move and say this deck most likely can get within 3 months you can get the approval now. So that's basically like the second part of the project where we looked at a much smaller subset of the data we had. It's not 400,000 planning application, but was 17,000. But we have around like 215 dimensions, like to each planning application, comprehensively good quality data. And using that 200 odd features we have, can we predict how long it will take for this application to get approved? The answers are like we can predict it, but it's not to an extent like of giving a number. But we can do an estimate of how likely it is to get approved with the 50 and 90% intervals. So this has been submitted. It's in peer review. So the preprint is available. So if you want to read and have that feedback, yeah, that's the link for that. Finally, future directions. So we think so. Being made some progress in answering such questions, like saying how many new links are in approved 27. We want to take it forward to answer more complex typology side. So, for example, if somebody asks like, how many granny flats are proposed in this suburb in the next 2 years? How much high density units? Like being able to like then pinpoint and extract pictures out. And being able to make also on the temporal side, we also want to push this towards it's just approval currently. So we just look at lodgement date and approval date, being able to then say what we know about the planning application. So when it will be constructed, when it will be delivered, when it will actually be in the process of planning application being lodged to constructed and somebody moving in, where it will we can do predicting when it will happen. So I would like to thank. So this project and the work has been done as part of ADAP, which is Australian Housing Data Analytics Platform, and currently Housing Analytics Lab. I'd like to thank all partners for the contribution for the work in terms of data, inputs, and resources. So we don't need this bit because we had the last seminar introduced that, but Housing Analytics Lab is UNSW Sydney Futures lab for looking at to support better housing outcomes for Australians, and it's both a physical and digital space. And yeah, so if you want to engage with the Housing Analytics Lab, to contact us. So I'm doing very good on time. The being said, like if you are doing or want to do similar work internationally, if you're interested in getting the ML AI models to do better predictions of do the same thing, the things which I've introduced better, or if you want to really engage with Housing Analytics Lab, reach out to us. That's me. Oh, we can.
Right. We do have one question from the chat at the moment, Bala. It's from Marco Toretto. They've asked, did you find any patterns around what types of applications were delayed most and why, or why applicants were refused?
Yeah, so that is explained by this one. So we can expand that other 200 to 2, but usually it's to do with the complexity of the application. The most impact is the complexity. So that's kind of inferred from cost, size, and like correlative. And if there is any changes to the zoning and related regulation, and the council makes a big difference, like which council it's been applied. So that's one. So if we had, however many dimensions we have here, and we can see the sharp value and see how it's impacting that. In terms of refusals, the data set of it's trained. It's hard because from experience, it's when a planning application gets rejected, getting that date of rejection, or if it is being rejected, is very hard. So the public consultation process doesn't show us when it's been what's the outcome. Even in the planning portal currently, the public data set doesn't have that. And even if it is, it's a very small data set. We are not able to actually do this for whether it will get approved or not. So assuming everything will get approved, we can just model the time frame. Hope that answers the question.
All right. Are there any further questions from anyone in the room online? Great.
As far as the different states are concerned, have you found much of a problem with inconsistent definitions of variables?
We haven't, primarily because the best data we had is for New South Wales, and we only did it for New South Wales. I think there might be variations across councils, but that's if we looked at. So to answer that question, we may have to improve the way we collect data from public consultation processes. And I believe there is like some improvements that could be done. So currently we might be able to use that data set better. And then we can look at like why some councils have a better approval times than others. So explaining that in detail, we should be able to do.
Yeah.
So the answer would be like, we have to improve the first study in terms of like what features we can get from our application.
Yeah.
Once we have a good enough model to do that, then we can look at it closely.
The intention is to go Australia wide, is it? Yeah.
So the first one, the data we collected through web scraping, that's Australia wide by default. Getting this kind of data, about 200, 300 odd features in each planning application. If we can do that Australia wide, we can compare states.
Yeah.
Yes.
Thank you.
Yeah, very interesting studies and then very great presentation. Thank you, Paula. I just have one question / comment. So can you move to the next slide? So my understanding is that in this second study, you modeled the time. So it's just that the duration takes for the applications to get approved. Is that correct?
Yes, yeah.
And then, so my question is that usually in these kind of, so have you considered survival analysis in terms of normal regression? Because I mean, the comment is because you have the outcome variable is duration and it is non-negative. And so did you consider survival models as well?
No, we haven't looked. So essentially, like the major constraint with this part of the study is the data size. So we spent so much time to get that number of variables high out. So we looked at random forest and XGBoost and then kind of like wrapped that up there. But I agree, there's like a lot more we can do because the number of features is so high. And although some of them are like engineered features, right? So we engineered based on other features, but we should be able to do that. So the answer is we haven't, but yes, we can.
Bill?
Yeah, look, really interesting, obviously. Just to clarify, these data sets give you the time or the timeline from the submission or the lodgement of the DA to the final decision, are they, yes or no? Have you thought about how you might extend that analysis by tying in kind of construction certificates and occupation certificate data to actually get to that kind of magic figure, which is what gets approved and then what actually gets delivered and occupied, because there must be a big drop off on that. We know there is. It'd be really interesting to be able to predict what DA is likely to get actually taken through to delivery.
Yeah. So broadly speaking, so to go back to the context, so it's the problem is kind of like we are looking at data which has been collected for some other purpose. So the data is made for planning approval process, right? So it's for the planning process, they collect this information. They put it out to public for a different process as well. So that's for public consultation. And what we are attempting to do is derive value out of it for a different purpose, for an aggregated knowledge purpose. So that's good. So in this, it's the key is finding a process which will help us identify information which is collected somewhere, which will give us that information. So construction is easy because we can see it. So when a building is finished, we can see it.
Well, it gets an occupation certificate as well. So you can't let anybody into it or sell the thing till you've got that.
So identifying those. So for example, I would say like this is just me thinking from top of it. When the building is constructed, we can see it through satellite. That's a classification. Again, visual classification problem. We can solve that. When somebody is approved to move in, could be in terms of like infrastructure provision. So if there is an internet connection there, so somebody's living there. So those kind of stuff like we can get and then start piecing together that information.
Also, just to say, Bill, it is a really big issue, and
Oh, yeah.
we have there's a PhD student who's now looking at that. But one of the issues, even just trying to bring, I mean, without the imagery, capturing, getting those data sets and being able to access them, as you know, is very difficult, and to join them.
That'll be better.
There's one of our PhD students is focused on that.
Yeah.
So the things which I've found, which we discussed with Will and I discussed, were swimming pools. Every swimming pool is registered in New South Wales. If we get the data, so we know if there is a development application with the swimming pool, and if the swimming pool is registered, we know it's been constructed. So those kind of connections we can start making multiple.
We can make them conceptually, but that's the other thing. If we get, I guess that's the big thing, the big challenge with a lot of this work is if we can get the data. Where is the data? Is it within Department of Planning? Is it, in a certified database of swimming pools? Where is it? So is it at council? Are there 20 different copies of it? Because there isn't a unique version of it. It's floating around everywhere. And if you collect them, you've got duplication. So that's
again, that brings me to the first slide, which I showed this complexities of the Ireland study. Basically, like the summary was like garbage in, garbage out kind of a thing, right? So when your system is so complex, there are like paper applications involved somewhere, things don't match up. So it's kind of like, then you can say it's not possible to do certain things because it doesn't support it. Then we may then can recommend to change it, but then it will be changed for the purpose it's built for, not for the purpose we want. So that's the kind of thing.
But the other thing I was going to ask is it this kind of methodology you could apply to other sorts of housing data to do other sorts of inquiry, to query about, I'm thinking we have masses of rental bond data, for example, and to use that in a way to predict turnover rates or that sort of thing. You could use this sort of
Definitely. So I think that's where the potential for such methodologies lie. These models been developed. So for example, the good example would be BERT. BERT is a code-only model, which has been developed to look at natural language processing by Google. So essentially, it was not, it gives us the ability to model meaning out of text, And we can take that potential and apply it like where we find it hard. So for example, a person can read a planning application and make sense of all these features. And if a seasoned planner can look at a planning application and give you advice on like, this will take 3 months to 1 year. And being able to get that, teach a model to do that similar one is where the potential is. Right? So then we start thinking about what are the features that went into making that judgment. How do you read it and understand it? So basically, like, then everything becomes pictures, images, text, and models are complex enough to understand the pattern of like making a judgment which a planner can make. Cool. We have some online questions.
Yeah.
Please reflect on the impact of such studies on local councils. Have they adopted some insights to speed up housing delivery? So these two studies specifically are not in the process of planning and approvals. So essentially, it's about looking at the data landscape and see how much value we can take out of that in terms of the. So we have had like people reach out to use this for tracking the supply perspective, right? So that's one we can see. Speed up housing delivery in terms of like this kind of data set gives us a good, I think uniquely gives us a way to look into the future and adjust things right now. So for example, if you have a target of like, let's say 800,000 units by end of 2029, and then we can then see like, okay, how many applications are in progress. So then if it doesn't match us, then what do we do right now to change things in the future? So that will be very helpful for that. Can the data help to keep tabs on when and if the development commences construction after it approved? Currently, as I said, like no, but it will be there. I'm fairly certain it's there somewhere for identifying it and being able to capture it in a quality that we can use. Do you envisage the variables or pointers differ from state to state or between councils? How it does predictions? Is there a model you are looking at that can determine approval time and outcome, factoring in council employment factors? Type of application law and type of construction being utilized. How fast? Yes. So the answer to both are yes. And the first one is, again, as I mentioned, it's about availability of data across councils and how interchangeable they are. The second one is these three factors are very interesting. If we can get them, it will be very interesting to see how we can model them. So on that, like I would like to note, like rather the more exciting thing for us in the second study is being able to see what factors are affected in each prediction. So that helps us a lot more. Cool. Any other questions?
No worries.
Yes.
Thank you, Bala, for a great presentation today, and thank you to the audience for joining us today as well. Just a reminder that our next seminar will be held in 2 weeks' time. We look forward to hearing from two of our excellent postgraduate students, William Van Wyck and Philip Grouse. William will present urban planning, non-statutory policy construction, envisaging a refined interpretive approach, and Philip will explore the question, how can urban design improve metropolitan planning outcomes? Thank you for your time, and I hope you all have a great afternoon.